SQA Higher Maths, Lesson 3 on the recurrence relation topic. So in Lesson 2 we were using a recurrence relation, and I mentioned that in this example the values seem to be converging, moving towards a certain value. So we started at 1.2 to 1.5, 1.65, 1.69, 1.71, 1.72. If we kept on going and going and going up to U10, U20, U30, U50, U100, we would indeed notice that it does converge towards a certain value. Before you look at the rest of this video, you should really get out your calculator and just prove to yourself that that does indeed happen. So pause this and have a go at doing that. Right, so there's a little bit of extra reading about that on page 75 and 76 from the Heinemann textbook. I'd like you to have a read of that as well, but I'm going to go into the limit of a recurrence relation. So as I was mentioning before, it looked as though in that example from the last lesson it was moving towards a certain value. We'd call that value it moves towards and sticks at the limit of the recurrence relation. So for a recurrence relation written like this, un plus 1 equals aun plus b. So a is just the coefficient of un and b is the number on the end. As long as a is between -1 and 1, now that's very important, a has got to be between -1 and 1. So example, minus -0.8 or 0 or 0.56 or 2/3 or -5/6. Then un tends to limit L. So when we just keep on pressing the buttons on the calculator and finding out U5, U10, U20, U100, it will converge towards a certain limit. Rather than this, all this number crunching on the calculator, it's just a formula. The limit is given by b over 1 minus a. So we'll look at what b is, we'll look at what a is, substitute the values in, and just find out what the limit is. So let's look at that being applied in an example. So Victoria Park Gardens are combed for litter every day, resulting in 80% of all litter being removed. Every day, however, 20 kilograms of litter is dropped in the gardens. What can be said about the mass of litter in the gardens after several weeks? So 80% of that litter has been removed. So again, when we're creating the recurrence relation, we're only looking at what is remaining. So there's 20% of that litter remains. So on the next day, un plus 1 will be 20% of what there was on the previous day, or the current day, even if we're looking at the next day. So 0.2 or 20% times un plus 20. The plus 20 is the 20 kilograms of litter that is dropped every day. So again, the next day there will be 20% of the litter from today plus another 20 kilograms. So that is our recurrence relation. We're asked to look after several weeks, so we could start pressing the buttons on the calculator, set it up, have a look after 3 weeks, 4 weeks, 2 weeks. What does the word several mean? It sounds a little bit vague. What it's really asking it for is look at the limit. What will the amount of litter tend towards? So again, rather than pressing the buttons on the calculator, substitute in. Here's our b, here's our a. b over 1 minus a will be 20 over 1 minus 0.2. So that's 20 over 0.8. We do need to have some non-calculator skills at higher maths, so let's just do that without a calculator. So I'm going to look at the equivalent fraction. I'm going to multiply top and bottom by 10. So that'll be 200 over 8. And 200 over 8 is 25. 25 eighths make 200. So L, the limit of the amount of litter, will be 25 kilograms. So after several weeks, the amount of litter will approach 25 kilograms. So that is the long-term limit. And that is how to find the limit of a recurrence relation. So have a go at these questions here, 5H, question 3 to 10 from your Heinemann textbook.